So today we are going to learn an important class of organometallic complexes. They are known as carbonyls or metal carbonyl complexes. Carbonyls or metal carbonyl complexes. Okay, these are actually the complexes formed between a metal and the carbon monoxide ligand, metal and carbon monoxide ligand. And you know the chemical structure of the carbon monoxide, and it has been formed by the bond between the carbon and the oxygen. Carbon has four valence electrons, and oxygen has six valence electrons. Both of them doesn't have the octet, so they enter into a chemical bond formation. So there will be a triple bond between carbon and oxygen, and there will be a lone pair in the oxygen and another lone pair in the carbon, okay, or unshared pair of electrons. Now you can count the electrons. Totally there should be 6 plus 4, that is equal to 10 electrons around carbon and oxygen. Now we can see how many electrons are there in around carbon and oxygen. 1, 2 from here, then 2, 2, 2. Okay, each bond is constructed by 2 electrons, so 3 bonds are there. For 3 bonds there are 6 electrons, and then again 2 electrons are here. So 2 here, and 6 electrons are here, and 2 electrons are here. 2 plus 6 plus 2, that is also equal to 10. So these 10 electrons of carbon and oxygen are distributed like this. Now you can count the share of electron for each atom in carbon monoxide, both for carbon and oxygen. In the case of oxygen, we can count the electrons 1, 2 from the pair, lone pair, then 3, 4, 5. 3, 4, 5 means each bonded electron, okay, bond pair of electron is shared by the carbon and oxygen. So from each bond, oxygen has a share of 1 electron. From 3 bonds, oxygen has the share of 3 electrons, then plus 2 electrons from the lone pair. So 3 plus 2, that is equal to 5. So oxygen has only 5 electrons. Oxygen has only 5 electrons, and in this one, the share of carbon, then 1, 2, 3, 4, 5, that is also 5, okay. But you can see that both of them have the octet. When we are counting the octet, we have to count like 2, then this carbon also has a pair here, okay, then 2, 2, 2, 6, then 2 here, 8, and again oxygen has 2, 2, 2, 6 plus 2, that is equal to 8. Both of them have the octet, but the oxygen has only 5 electrons, therefore it gets a negative positive charge, because oxygen should have 6 electrons in its valence shell. Now 1 electron is less, therefore it has a positive charge. Okay, we can assign a positive charge to oxygen, and carbon has 1 electron more, because carbon should have only 4 electrons, then it has 1 electron more, then it has and then it has 1 negative charge. Okay, so it has a positive, oxygen has a positive, and the carbon has a negative charge. So if we are writing the we are writing the structure with the formal charges, we can write it like a carbon triple bond oxygen, positive and negative. You can write like this. See, here you can see that the carbon bears a unshared pair of electron, and at the same time carbon has a negative charge, a formal negative charge. Therefore, this unshared pair of electron is ready to be donated, right? It is ready to be donated. And this unshared pair of electron will be donated to the vacant orbital of the metal, so that there will be a coordinate bond formation between the carbon of carbon monoxide and the metal. That is how the metal carbonyls are forming. So in the metal, there will be vacant orbitals, means orbitals having no electrons, and it will be that orbital will be filled by the orbital of the carbon monoxide, which already bears two electrons, and this orbital is originating from carbon, so that there will be a carbon oxygen bond. Okay, so this will be the positive, and this shared pair of electron of the carbon, this a pair of electron of the carbon is shared between metal, so we can formally give the negative sign here, because metal gets the additional electron, and this electron pair is shared between metal and carbon. Originally it was of carbon, now carbon loses one electron, and that, because of losing one electron, it loses its negative charge also, but metal gets an electron, so formal charge can be given to the metal. So the metal carbonyl oxygen bond can be written like this: M minus, then there is a bond between metal and carbon, and then a triple bond with oxygen with a negative charge, and it can have another structure like M double bond C double bond O. Okay, okay, it can be like this also. Okay, and now we know how the metal carbonyls are being formed, right? The means there will be a bond formation between the carbon monoxide and the metal, and metal carbonyl bond is formed. Okay, sorry, I put negative charge here. It is positive, yeah, yeah. Okay, so the metal carbonyl bond is formed, and such complexes are called metal carbonyls. Metal carbonyls. We are going to learn about these metal carbonyls. Okay, and before proceeding to the details of the metal carbonates, actually I am going to give only an introduction in this topic. We have to learn certain things or certain common features of the metal carbonates, or some interesting chemistry regarding the metal carbonates. Okay, first of all, you have to understand that carbon monoxide is not a very good Lewis base. Okay, CO is not a very good Lewis base. What is Lewis base? Okay, if a ligand can donate its unshared pair of electron to the metal, then we can call that ligand as the Lewis base. Carbon monoxide is giving the unshared pair of electron to the metal, therefore we can call carbon monoxide as a Lewis base, right? കാർബൺ മോണോക്സൈഡ് ലൂയിസ് ബേസ് ആണ്, എങ്കിൽ കൂടിയും കാർബൺ മോണോക്സൈഡ് ഒരു അത്ര നല്ല ഒരു ലൂയിസ് ബേസ് അല്ല. അങ്ങനെ ഒരു ഫാക്ട് നമ്മൾ മനസ്സിലാക്കിയിരിക്കണം. സ്റ്റിൽ ഈവൻ വൈ ഐ മെൻഷൻ ദിസ്, ബിക്കോസ് സാധാരണ നല്ല ലൂയിസ് ബേസ് അല്ല എന്നുണ്ടെങ്കിൽ അത് നല്ല സ്ട്രോങ് ബോണ്ട്സ് ഫോം ചെയ്യത്തില്ല. Even if carbon monoxide is not a very good Lewis base, we have to understand that it forms, or it makes strong bonds. Make strong bonds. Strong bonds. Okay, that is one interesting facts regarding the metal carbonyls. The second interesting fact is that these metal carbonyls are formed by metals which are normally in their low oxidation stage. So metals normally in the low oxidation stage. Normally in the low oxidation stage. Okay, it means that sometimes the oxidation state may be zero. Okay, the oxidation state may be zero, or it may be slightly positive, or something like +1. Okay, slightly positive, or it can be sometimes negative oxidation state also, -1 like that. Okay, so these type of metals are forming the metal carbonate. So when if a metal is forming the metal carbonate, you can normally observe that that metal is going to be in the low oxidation state. Very normally or very usually metal will be in the zero oxidation state, or it can be sometimes it can be low positive like +1, or even sometimes +2, and or even it can be sometimes negative of oxidation stage. Okay, that is another interesting fact. And one more interesting fact about the metal carbonyls I am going to say, that is 99 percentage of metal carbonyls, and they obey 18 electron rule. Okay, so most of these metal carbonyls are obeying 18 electron rule. These are the three interesting facts I have to mention at the beginning itself about the metal carbonyls. എന്താണ് കാർബൺ മോണോക്സൈഡ് എന്ന് പറയുന്നത് ഒരു നല്ല ലൂയിസ് ബേസ് അല്ലെങ്കിൽ പോലും മെറ്റൽ കാർബണൈഡ്സിൽ കാർബൺ മെറ്റൽ ബോണ്ട് എന്ന് പറയുന്നത് സാധാരണഗതിയിൽ സ്ട്രോങ് ബോണ്ടാണ്. ഓക്കെ, ഇനിയും രണ്ടാമതൊരു കാര്യം പറഞ്ഞത്, നിങ്ങൾ മെറ്റൽ കാർബണൈൽസ് എടുത്തു കഴിഞ്ഞാൽ മിക്കവാറും മെറ്റൽ കാർബണൈൽസിലും മെറ്റൽസ് എന്ന് പറയുന്നത് ലോ ഓക്സിഡേഷൻ സ്റ്റേറ്റ് ആയിരിക്കും, മിക്കപ്പോഴും 0 ആയിരിക്കും, അല്ലെങ്കിൽ സ്ലൈറ്റ്ലി പോസിറ്റീവ് ആയിരിക്കും, ലോ പോസിറ്റീവ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ് ആയിരിക്കും, അല്ലെങ്കിൽ ചില കേസുകളിൽ നെഗറ്റീവ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ്സ് പോലും നിങ്ങൾക്ക് കാണാൻ സാധിക്കും. മൂന്നാമത്തെ കാര്യം പറഞ്ഞത്, മോസ്റ്റ് ഓഫ് ദ മെറ്റൽ കാർബണൈൽസ് will obey 18 electron rule. Okay, and now let us learn something more about the metal carbonyls. You can see different kinds of metal carbonyls. Okay, for example, you can see a type of metal carbonyl like MCON times. Here there is only one metal center. Okay, such metal carbonyls are called mononuclear. This is mononuclear metal carbonyl. For example, NiCO4 times, that's a mononuclear metal carbonyl, because there is only one metal center in this complex. And sometimes it can be like this, MXCOY times, means there will be more than one metal centers. Okay, and in such cases we call them as polynuclear. Okay, and for example, you can see this type of a complex, that is Mn2CO10 times, Mn2CO10 times. Here two manganese centers are there, so this is a polynuclear metal carbonate. But in these two cases, in both cases, you can see only carbonyl ligands. All the ligands in this complex are carbonyl ligands. All the ligands in this complex are also carbonyl ligands. So if you are seeing only one type of ligand in an organometallic complex, you can call them as homoleptic complex. So these two are homoleptic complexes. Okay, so then since they bear only one type of ligand, that is the carbonyl ligands. So most of these carbonyls are homoleptic carbonyls that we are going to study. And there are other carbonyls also, means that sometimes there can be a mixture of ligands. More than one type of ligands may be present in the metal carbonyl. For example, it is like MRX, okay, RX times, and ZOY times. Okay, so sometimes the carbonyl may be like this. This is also a carbonyl, but this is all the ligands in this complex are not carbonyl. Some other ligands are also there. R is given here. Okay, R can be anything. For example, R can be a phosphine ligand. For example, you can see this one, FeZO. Sorry, let me write it clearly. FeCO 4 times PPS3, 4 times PPS3. Triphenyl phosphane ligand is there. Triphenyl phosphane ligand. Okay, this is triphenyl phosphane ligand. So here R is PPS3. So a mixture of ligands are there in this complex, and such complexes are called heteroleptic complexes. Heteroleptic. So the carbonyls can be either homoleptic or heteroleptic. Okay, and here we have seen that both the carbonyls can be mononuclear and polynuclear. And here, before proceeding, I will show you the periodic table of elements. I will not show the full periodic table of elements. I will show you only the transition metals. Okay, this is these are the transition metals, and I will show you which of these will form the carbonyls. Okay, I will show which of these are going to form the carbonyls. And scantium, this group, they are not going to form the carbonyls. Titanium, these are also not going to form the carbonyls. I am talking about the homoleptic carbonyl complexes. Either it can be mononuclear or polynuclear. Okay, I am talking which of these are going to give the mononuclear or polynuclear homoleptic carbonyl complexes. Okay, and then scandium, titanium, these groups are not going to give the stable carbonyl complexes. And here we have the leg. Vanadium is giving the vanadium is giving the carbonyl complex, a stable carbonyl complex. Then after vanadium, none of these ligands, none of these metals in this group are giving the means the third or second or third row are not going to give the carbonyls. We are considering only second and third row. We are not bothered about the fourth row. The carbonyls you can't see there. Okay, the vanadium only is giving the carbonyl complex in this group, and then we come to the next. Okay, the chromium. Okay, this also giving, this will also give the carbonyl complex. Okay, and in this group both the second and the third, both of them will give the carbonyl complex. So molybdenum will also give the carbonyl complex, and tungsten will also give the carbonyl complex. Okay, and if you are moving to the next group, manganese will give the carbonyl complex, homoleptic carbonyl complex. Then technetium is also giving the carbonyl complex. Then rhenium is also giving the carbonyl complex. Okay, then we move to the next group, iron. Okay, then ruthenium. Okay, ruthenium, and then osmium. Okay, osmium, this will also give the carbonyl complex. Then we go to the next, cobalt. Okay, then rhodium and iridium, and then we move to the last, that is nickel. Okay, nickel will also give a carbonyl complex, homoleptic carbonyl complex, but the elements below nickel are not going to give. So these are the metals among the first, second and third row transition elements which are going to give homoleptic carbonyl complexes. It can be either mononuclear or polynuclear. It is very easy to remember, right? Very easy to remember. You can see from the scandium and titanium are not giving. First two out of these are not giving the stable homoleptic carbonyl complexes, and the last two are also not giving. Okay, last two are also not giving, and all the middle are giving. All of them, all in the first row, from vanadium to nickel are giving, but when we are coming to the second and third row, only chromium, manganese, iron, cobalt groups. Okay, only these groups are giving the carbonyl complexes for all first, second, and third row. Okay, others are not giving. Okay, so you can easily remember this. These are the metals in the periodic table which are giving homoleptic carbonyl complexes, either polynuclear or mononuclear. And now let us talk about the mononuclear carbonyl complexes. Mononuclear carbonyl complexes. Okay, so mononuclear carbonyl complexes. I will draw actually a table for these elements. Then I can write there. Okay, and I will write here. Here I will write the elements. Which are these elements? Okay. First, the vanadium. Vanadium. I'm sorry. First, vanadium. Then chromium. Then manganese. Then iron. Okay. Then cobalt. And then nickel. Okay. So these are the first row elements, and I will show which of these are going to give the mononuclear carbonyl complexes. Okay, actually the mononuclear carbonyl complexes are given by metals with an even atomic number. Mononuclear carbonyls are given by metals with an even atomic number. Okay, mononuclear mononuclear are given by metals with a even atomic number. Even atomic number. So we can check which are having the even atomic number. Uh, Vanadium, no, the chromium, and then iron and nickel. Chromium 24, iron 26, and nickel 28. They have the even atomic number. So they are giving the mononuclear carbonyl complexes. So let us write chromium. The chromium is giving chromium CO6 times. Chromium CO6 times. Okay. So this is a mononuclear carbonyl complex. After chromium, then comes iron. Iron is also having even atomic number, so it is giving a mononuclear carbonyl complex. FeCO5 times, FeCO5 times, and then comes nickel. Okay, nickel is also giving the mononuclear carbonyl complex, nickel CO4 times. Okay, so these are giving the mononuclear carbonyl complexes. And not only that, if you can see the other elements in the third and the other elements in the second and the third rows, just below the chromium, they are also having the even atomic number, right? They are also giving mononuclear carbonyl complexes. So we can also write for the second row, and we can write it for the second row. Let me draw the second row. Second row here. So in the second row, just below chromium we have molybdenum. Molybdenum is also giving the mononuclear carbonyl complex. So we have MoCO6 times. MO, sorry, MoCO6 times. MoCO6 times. And in the third row we have a tungsten. Okay, in the third row we have tungsten. So I will draw the third row. The third row we have a tungsten. Sorry, let me choose. Yeah, I can choose the color later. The third row we have a tungsten, and I will write the tungsten here. Tungsten WZO 6 times. Okay, so all these have the even atomic number and they give a mononuclear carbonyl complexes: chromium, molybdenum, tungsten. Then in the iron group we have other elements. Below iron we have uh, ruthenium and osmium, right? Ruthenium and osmium. They also give mononuclear carbonyl complexes. Just below iron, ruthenium, ruthenium CO 5 times. Okay, and we have osmium CO 5 times. Osmium CO 5 times. Okay, this is also there. And in the case of nickel, there are elements below nickel, but they are not giving the carbonyl complexes. We already said that, right? They are not giving the carbonyl complexes below nickel. So these are the mononuclear carbonyl complexes that you can see. And now there is an exemption. The exception is that see, vanadium, it has atomic number 23. Okay, atomic number is 23. So even if its atomic number is 23, which is an odd number, this vanadium is also giving a mononuclear carbonyl complex. So this is an exemption. CO, vanadium CO 6 times. This is a stable organometallic carbonyl complex. Vanadium CO 6 times. So even if vanadium has the odd atomic number, it gives carbonyl complex, mononuclear carbonyl complex. Now let us come to the polynuclear carbonyl complexes. Polynuclear carbonyl complexes. Polynuclear. Polynuclear carbonyl complexes. Generally, metals with odd atomic number. Okay. Generally, that is very correct, very important. Or normally, metals with a odd atomic number are giving this type of complexes, this type of carbonyl complexes. But this rule is not very strictly correct. There are many exemptions for this one. For example, vanadium, it has odd atomic number. Vanadium is atomic number is 23. So even if its atomic number is 23, it is not giving the polynuclear complex. It gives a mononuclear complex. That is an exemption, right? So vanadium does not have a polynuclear carbonyl complex. Now there are many more exemptions. For example, metals in the iron group also form polynuclear complexes. We will talk about the exemptions later. First of all, we will see the metals which is the odd atomic number, okay, which are giving the polynuclear complexes. Here, manganese, the atomic number is 25, and therefore manganese is giving a polynuclear carbonyl. The carbonyl complex is Mn2CO 10 times. Okay, this is a polynuclear carbonyl complex given by manganese. And other elements in that group, below manganese we have technetium and rhenium. They are also giving polynuclear complexes. For example, technetium. Okay, technetium, and this will also give a polynuclear complex, that is technetium Tc2 CO 10 times, CO 10 times. Okay, this is also a polynuclear carbonyl complex. Then rhenium, okay, and this will also give a polynuclear carbonyl complex, Re2CO 10 times. Okay, so all these are giving the polynuclear carbonyl complex. This is very easy to remember. Mn2CO 10 times, Tc2CO 10 times, Re2CO 10 times. These are giving polynuclear complexes. And then we have cobalt. Cobalt is having the atomic number which is equal to 27. It's an odd atomic number, that is also giving polynuclear complex, that is CO2 cobalt to CO 8 times, CO 8 times. Okay, that's a polynuclear complex. Okay, and not only that, cobalt is giving another polynuclear complex, that is CO4 times CO 12 times carbonyl 12 times. This is also given by cobalt. Okay, not only that, cobalt is again giving CO6 times CO6 times 6 times CO 16. These are also the polynuclear complexes given by cobalt. Okay, and then when we are coming to the next, and below cobalt we have rhodium and iridium. So just come to the second row, rhodium. Rhodium is giving RH4 times CO 12 times CO 12 times. Okay, it is like cobalt for CO 12 times. And not only that, it also giving RH6 CO 16 times. RH6 CO 16 times. It is like cobalt 6 CO 16 times. So it is very easy to remember these things. Okay. Then when we are coming to the next row, that is the third row, then we have iridium there. And iridium is also giving the polynuclear complex. For example, iridium 4 times CO 12 times CO 12 times, just like RH4 CO 12 times. And it is also giving iridium 6 times, iridium 6 times CO 16 times. Okay, so very easy to remember, RH6 CO 16, iridium 6 CO 6 times. Okay, and in this group you can see that only cobalt is giving the binuclear complex. Others are giving complexes with 4 metal centers or 6 metal centers. Okay, so tetranuclear or hexanuclear carbonyls they are giving. Cobalt is giving binuclear also. In other cases, means in the case of rhodium and iridium, they are giving tetranuclear and hexanuclear carbonyl complexes. Okay, that you can remember. And these are the elements with even atomic number, right? Now we talked about chromium, and then we talked about not what atomic number. We talked about vanadium. Vanadium is giving only mononuclear, that is an exemption. And then we talked about manganese group, and also we talked about cobalt group. Okay, now I said that there are some exemptions. Some with the even atomic number are also giving polynuclear complexes. We can look at the ones with the even atomic number. Okay, for example, we can look at this which one? Yeah, even atomic number. Chromium, molybdenum, and tungsten. Okay, chromium, molybdenum, and tungsten, they are giving only mononuclear complexes. There is no exemption there. And then if we are coming to the next, iron, ruthenium, and osmium. Okay, there we can see the exemptions: iron, ruthenium, and osmium. Even if its atomic number is an even atomic number, it is giving the polynuclear complexes also. For example, you can see the polynuclear complex of iron. Okay, for example, it is Fe2 CO 9 times, Fe2 CO 9 times. That is a polynuclear complex. Or you can see Fe3, then CO 12 times, CO 12 times. Okay, these are also polynuclear complexes. So even if iron's atomic number is even, it is giving the polynuclear complexes. And then when we are coming to the next element, that is ruthenium, its atomic number is 44, which is an even atomic number. Still, it is giving polynuclear complexes. For example, you can see Ru3CO 12 times. Ru3Zo12 times. Okay, that's a polynuclear complex. And then we are coming to the next one, that is osmium. Here, it is also giving polynuclear complex, that is OS3 CO12 times. CO12 times. This is also a polynuclear complex. Okay, so these are the different metal carbonyls you can see for the first, second, and third row transition elements. Okay, these are the different metal carbonyls. We talked only about the homolytic metal carbonyl complexes, both mononuclear and polynuclear. Okay, so I hope you understood this much. And today we talked about the carbonyls, and we saw that the carbon monoxide ligand is making bond with the metal, and then the metal carbon bond is established, and such complexes are, we call these complexes are metal carbonyls. Okay, we will talk about the bonding in detail later. In the next or in the coming video, I will explain the bonding in much more deep, in a much more deeper fashion. Okay, so then you will understand about the bonding more clearly. Okay, today I gave only a rough picture of the bonding, just to have an introduction. Okay, and then we talked about the various interesting factors about the metal carbonates, and also I introduced which are the transition metal complexes are which give the homolytic metal carbonate complexes, and now you understood which are giving the mononuclear and the polynuclear metal carbonate complexes. I hope you have you have a good introduction to the metal carbonate complexes, and in the coming classes we will learn more. അപ്പോൾ ഇത്രയും കാര്യങ്ങൾ നിങ്ങൾക്ക് മനസ്സിലായെന്നുണ്ടെങ്കിൽ നമുക്ക് മെറ്റൽ കാർബണേറ്റ്സിനെ പറ്റി അടുത്ത ക്ലാസ്സുകളിൽ കൂടുതൽ വിശദമായിട്ട് പഠിക്കാം. നിങ്ങൾക്ക് എന്തെങ്കിലും സംശയങ്ങളുണ്ടെങ്കിൽ ഡോണ്ട് ഹെസിറ്റേറ്റ് ടു കോൺടാക്ട് മീ ഇൻ എനി വേ. ഓക്കെ, നിങ്ങൾക്ക് എന്നെ വാട്സപ്പിൽ കോൺടാക്ട് ചെയ്യാം, അല്ലാന്നുണ്ടെങ്കിൽ ഇവിടെ യൂട്യൂബിൻ്റെ കമൻ്റായിട്ട് നിങ്ങൾക്ക് നിങ്ങളുടെ സംശയങ്ങൾ എഴുതി ചോദിക്കാം. ഞാൻ നിങ്ങളെ ഹെൽപ്പ് ചെയ്യാൻ തയ്യാറാണ്. ഓക്കെ, അപ്പോൾ എല്ലാവരും വാച്ച് ചെയ്തതിന് എല്ലാവർക്കും നന്ദി. എല്ലാവരും നന്നായിട്ട് പഠിക്കുക, എക്സാമിനേഷന് വേണ്ടി തയ്യാറാവുക. എത്രയും പെട്ടെന്ന് നമ്മുടെ എക്സാമിനേഷൻ വരുന്നതായിരിക്കും. അപ്പോൾ എല്ലാവരും എക്സാമിനേഷന് വേണ്ടി തയ്യാറായിരിക്കുക. ഓക്കെ, അപ്പോൾ എല്ലാവർക്കും എല്ലാവരും ഇത് കണ്ട് അവരുടെ നോട്ട്സ് നിങ്ങൾ തന്നെത്താനും ഉണ്ടാക്കിയെടുക്കണം കേട്ടോ. നിങ്ങൾ ഈ യൂട്യൂബ് വീഡിയോ കാണുമ്പോൾ തന്നെ നിങ്ങളുടെ നോട്ട് ബുക്ക് കൂടി എടുത്ത് വെച്ച് നിങ്ങൾ നോട്ട്സ് കൂടി തയ്യാറാക്കി കൊണ്ടുപോകണം. നിങ്ങളുടെ നോട്ട്സിന് ഈ യൂട്യൂബ് വീഡിയോ മാത്രമല്ല, മറ്റ് സോഴ്സുകൾ കൂടി നിങ്ങൾക്ക് റെഫർ ചെയ്യാം. ഞാൻ ഇവിടെ റെഫർ ചെയ്തിരിക്കുന്ന ടെക്സ്റ്റ് ബുക്കുകൾ ഏതൊക്കെയാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ, ഒന്നാമത് ഞാൻ ഹ്യൂഹിയുടെ ടെക്സ്റ്റ് ബുക്ക് റെഫർ ചെയ്തിട്ടുണ്ട്. മാത്രമല്ല ഞാൻ കാതറിൻ ഹൗസ്ക്രോഫ്റ്റ് ഷാർപ്പ് അവരുടെ ഇനോർഗാനിക് കെമിസ്ട്രി കൂടി റെഫർ ചെയ്തിട്ടുണ്ട്. ഈ രണ്ട് ടെക്സ്റ്റ് ബുക്കുകളാണ് ഞാൻ പ്രധാനമായിട്ടും ഇവിടെ റെഫർ ചെയ്തിരിക്കുന്നത്. ഓക്കെ, അപ്പം നിങ്ങൾ എല്ലാവരും അതുപോലെ ടെക്സ്റ്റ് ബുക്കുകൾ കൂടി റെഫർ ചെയ്യുക. നന്നായിട്ട് നോട്ട്സ് പ്രിപ്പയർ ചെയ്ത് എക്സാമിനേഷന് വേണ്ടി എടുക്കാൻ ഇപ്പോഴേ തുടങ്ങുക. ഓക്കെ, അപ്പം ഇത്രയും നേരം കണ്ടതിന് നന്ദി. വീണ്ടും കാണാം.